Good morning, ladies and gentlemen. Welcome back here at the public forum at the Hydrogen Fuel Cells Europe here at Hannovermesse 2022. Yes, we are back here after 2 years, let's call it break, and we are thrilled and excited to continue our discussions in the public forum. We are also live streaming from the fair, so hello to all our online guests, and also all the videos will be on our website. So please enjoy your seat, have a coffee on the house, it's all on me. We are going to discuss integrated toolchain for mastering fuel cell development challenges. And for that, please welcome with me on stage the Principal Research and Technology Manager from AVL, Mr. Reinhard Tatschl. Welcome, Reinhard. It's nice to have you back here at the fair. How is it going for you? It was a break, and now AVL List is back here. What is your impression of this year's fair?
Yeah, first of all, thank you very much for giving me the chance to be here, to discuss with you a bit and have a possibility to outline a bit our view and our strategy in fuel cell development. And yes, it's a great show. It's a great experience again after 2 years of having a very quiet and let's say quiet time without any events or with events in another format, mainly online. So it's great to be back on stage. Great to be back to Hanover.
Yeah, it's nice to have you back here because AVL has a long history. I wouldn't say the longest, but I think one of the longest history when it comes to innovation in the hydrogen context. So I'm actually really proud to have you here. And I also would like you to elaborate on why your company, AVL, has been doing research and also applications regarding hydrogen business for such a long time.
As you probably know, we're large, privately owned, the largest, in fact, privately owned independent company for simulation, testing, and development of all kinds of powertrain systems, and also active in related areas. And these powertrain systems, they comprise the traditional powertrain, all kinds of hybrid powertrains, and electrified powertrains, battery electric, and also fuel cell electric powertrains. And our founder or our owner and CEO, Professor Helmut Litt, he very early, already 20 years back, he recognized that hydrogen and fuel cell is an excellent alternative or complementary solution for all kinds of mobility applications. And in the early 2000s, we started off with the first research programs in the fuel cell area.
And at that time, he was a pioneer. And I think it's okay to mention his age, right?
Sure.
Yeah, he's more than 80 years old and still active as a company owner and also driving, let's call it, business forward. So congratulations. And I think this is so important to get to know the people behind the company. That's why I'm so happy to have you here as well.
Yeah, it's definitely it's the pioneering spirit of Professor List that drives the innovation, and the hydrogen, our fuel cell activities are one example of that, which we can see here that it's absolutely the right technology that can contribute to a cleaner, affordable, CO2 neutral, CO2-free mobility and society in general in the next years to come.
Yeah, and I'm really happy that we are discussing this because I think we just chatted about this. It's so important to have avant-garde, forward-thinking people to believe in a technology, to push it, that we have a results. We started here in 1995 with 8 exhibitors, or 7, and now we're here with more than 200 exhibitors from 20 different countries, so that's really impressive. I would like to know from you why you chose your title, Integrated Toolchain for Mastering Fuel Cell Development Challenges.
Well, the compared to traditional propulsion systems, yeah, with 100 years of history and a lot of experience in the community, um, the hydrogen and fuel cell technology is um, is rather new in the focus, and there's certainly a number of let's say engineering and technical challenges to overcome, to master, related to costs, related to durability, related to efficiency, and and here simulation and testing, and especially the combination of simulation and testing uh, can help to find solutions in a very fast and efficient manner, gives you the possibility on a virtual basis on the computer to analyze hundreds or thousands of design variants, of control architecture, control concepts very efficiently. And it is this interplay of scalable simulation solutions combined with testing solutions that helps also to front load development activities from later phases in the development process to the early phases before the first hardware prototypes exist.
Um, I want to take one step back and understand what are exactly. Can you give some example of challenges that we have in fuel cell development?
Yeah, well, let's take the PEM fuel cell, and in the heart of the PEM fuel cell, you have the membrane, uh, the catalytically coated membrane, where the fuel, so the hydrogen and the oxygen, comes together and converted to water and then produces the electricity. And the efficiency and the lifetime of the core components of the membrane, of the gas diffusion layers, and also the efficiency is very much dependent that the species um, arrive at the right place in the right time and fully utilize the entire cross section. And due to the, let's say, the complexity, or due to the nature of the system, there are no non-intrusive techniques to look into the cell. With the simulation, especially with 3D multiphysics simulation, you have the chance that you really look into the details of the geometrical peculiarities, into the material properties, and get a spatially resolved and time resolved insight into the transport and conversion processes.
Okay. Why is simulation so important?
Yeah, the one is that it's very difficult or even impossible to experimentally to look into the details of the transport and conversion processes, and with the simulation you can make that visible, understandable to the engineer. He can look at the simulation results, he can see or identify areas which are lacking of hydrogen, for instance, which exhibit maybe excessively high temperatures, and he can derive measures how to improve that, how to ensure that the entire cross section receives the amount of hydrogen and oxygen that's required for the efficient conversion process.
So, for which type of fuel cells or do you do the simulation? Is that PEM or also SOFC?
Uh, we do that also for solid oxide fuel cells. We do that also for different types of electrolyzers. And that's one type of application to look into the very details of the cell and stack components. And when we zoom out a bit, um, then there are other challenges on a broader stack level. For instance, it's the media supply and the cooling optimization on a stack level to ensure that the individual cell layers in the stack all receive the same amount of fuel and oxidizer, that the cooling efficiency is as homogeneous as possible among the entire stack configuration. And if you further zoom out, so in order to get the stack supplied with the hydrogen and oxygen, you need um, what's called the balance of plant. You need the anode and the cathode supply channels. You need the cooling system, the thermal management system around. And the anode and cathode subsystems, they again are composed of a number of subcomponents and components, the air blower, humidifier, water separator. All these elements and components have to fit together in order to being able to supply the stack with the right amount of fuel and oxygen over the entire operating parameter space. And here system simulation in this context helps the engineer to do the right sizing, dimensioning of the individual components.
And I think that simulation, but also testing, can be very effective also with the cost reduction, not only with the performance increasement, but really bringing down the cost in the development phase.
Definitely, and so in the early development phase, doing things on a fully virtual basis, you do not have any hardware available, and you don't need any hardware in this early phase, and hardware is always rather expensive, and so you can do on a virtual basis, you can do a lot of analysis and pre-optimization, and once you've found in the office an optimal configuration, or maybe 2 or 3 optimum variants, you then go into the hardware procurement and then go on the test bed with that and the final optimization.
If anyone from the audience has a question at this time, you can raise your hand or let me know, and I will come down to you. This is your chance to ask questions. Just let me know, okay? Thank you. Okay, so we talked about AVL's simulation, and you mentioned that you also do testing and engineering. Is that right?
That's correct.
Okay. I want to talk a little bit about testing with AVL. So how does testing of fuel cell and hydrogen equipment look like?
Well, we're supporting the let's say the industry with test equipment and test methods from the cell level and the stack level to system level to entire vehicle test
Okay.
level.
Yeah.
So on cell and stack level, it's Green Light Innovation is the brand that is supporting
And
test
Greenland
equipment.
Innovation is also exhibiting here.
It's aside our AVL booth here in the area, yeah. And so they provide cell and stack test equipment, and on AVL side we offer system testing solutions, and as I said, vehicle testing.
But- So is it the testing solution that you're selling, or is it testing that I can do with my newly developed fuel cell, and I can do in-house testing with you?
It's well, we are marketing and selling the test cells, the test equipment, and we're also offering testing as a service, as we do with simulation. So we do offer in the market our simulation tools, multiphysics, 3D CFD, and also multi-physics system simulation tools. And in the same way, we do that with the testing equipment, so tools and services.
For that, I would like to know in which market is AVL active?
Well, we are operating on a worldwide scale, so we have nearly 11,000 employees.
11,000 employees?
Yes, all over the world in 45 affiliates. So virtually everywhere where there's an automotive industry, we're present there with local affiliates and up to technical centers of considerable size, supporting our customers with testing and simulation solutions.
Who is your usual customer?
Well, it's OEMs, supply industry, and it's also the research community. So research providers, academia, universities, they are also served by us.
Unfortunately, we are almost running out of time, but I would like to help a little bit out here. So, who do you think should come to your booth and have a more bilateral chat with you? What kind of customer should come and visit you?
Well, that starts from the cell and stack developing companies, also the supply industry that provides individual components, like for instance the membrane manufacturers or our manufacturers of gas diffusion layers, bipolar plates manufacturers, coders, system integrators, and and also OEMs, and not only from the automotive industry, but also from the related sectors. So we see a very strong momentum in electrolyzer technology for hydrogen production, for green hydrogen production, whether it's PEM electrolyzer, whether it's high temperature solid oxide electrolyzers. So all these, I'm sure, can find interesting solutions at our booth, and we really would like to invite everybody to come to us to have a chat and discuss about this challenging topic related to fuel cell and electrolyzer development.
Definitely, and I can highly recommend a visit. And you will have chat with very passionate people, very knowledgeable, and a company that has been established for a very long time is really hard driven towards the topic. So thank you very much, Reinhard. It was a pleasure to have you here. It's a pleasure to have you here, your company here. Will you be here next year?
Definitely, yeah.
I would be
happy.
very happy. Thank you so much.
Thank you.